welcome to my session on schema-driven observability, and it's another observability talk. For whatever reason, every SRE conference has mostly observability talks, I found out. Just wanted to check in, are we okay? Do we need more observability talks? I know I'm part of the issue, but there are other interesting topics as well. But yeah, my talk is about schema-driven observability with OpenTelemetry Weaver, and that's a whole bunch of magic words. So we're gonna start a bit slower and start with schema-driven observability. What could that be? Let's first look at a code example of how we do instrumentation right now. So this is Go, and we have a new metric we define. We have a name, help text, some attributes there, and then we instantiate those values, record a value of 1.2. Anyone see an issue with that? Anyone see that there are two issues hidden in that? There will be something going wrong at runtime. Anyone, even if you're not a Go developer, there's a very big issue. And the solution, or the cause for the issue, is we define two different attributes we can add here, but then we actually provide three. And in the Go Prometheus implementation, this will actually crash your program at runtime. So we only registered the method and the code, but we actually pass method, code, and then /login. And even worse, we mixed up the ordering of the values. So the first value should be the method, the second one should be the return code. This is all messed up as well. And this is an issue that won't crash your program, but you just will have bad data. So yeah, this all comes down to the famous two hard things of software development, which are, it's a bit slow, naming things, cache invalidation, and anyone? Yeah, you're right. This went way better than at the last conference. Nobody got that. So all of these are pretty fun to focus on, but for this talk, we're just going to focus on naming things, as that is the issue in the previous example. So to get us all on the same page, this is a metric. It's a Prometheus-style metric, but the same kind of techniques apply to other styles of metrics as well. It consists of a name, it consists of a label or attribute, and that attribute has a value. So the metric is called HTTP request total. We have a service name attached to it, which has the value up front. And this is cool. So you can name this whatever you want. And yeah, developers have freedom. So we're debugging an issue. We're in the zone figuring out why our service is down. We take a look at our metrics and see, okay, the request rate for the front end is good. That's good. We have mostly 200 responses. Let's check out if the backend is there as well. No. I just don't get any data. Now, why could that be? It could be because the backend is not sending any data. It could be because the service name is wrong. It's not called backend at all. It's called something different. It could be because the metric name is different, because our front end is using HTTP request total, while the backend is using HTTP duration, seconds, count, whatever. Or it could be because the label is wrong. It's not called service name, but it's called job in the backend. That sucks, because all of these things are things people can get wrong, and they will get wrong. So what do we need? We need a schema. This is where the next word in my title comes in, OpenTelemetry. The OpenTelemetry project has started building semantic conventions. Now, these semantic conventions are agreed upon names for metrics and attributes and logs and traces and everything else. So the community came together and said, hey, we all have different names for how we want to call an HTTP metric. We're going to standardize on one and recommend it to all the other implementations. There are versions, so you can follow specific versions of the semantic conventions, and they're community maintained. So if you're maintaining a very specific part of software development, like building a very specific product that has widespread adoption, you might want to contribute there and say, hey, we're very knowledgeable about network observability, so I'm going to add to the semantic conventions for network observability and make sure that everything is standardized and cross-compatible. And many things are in there already. There are semantic conventions for networking. There are ones for HTTP, hardware metrics, CI/CD, AI, of course, everything you need and more. So what does this look like? In this example, we have the HTTP server request duration metric. This is a pretty common one. So this is for HTTP server implementation. So if you're serving something, you want to increase that or track your request duration in that metric. It has a name. It has an instrument type, which is also very important to standardize on. You don't want to have a gauge metric going up and down in one application, a counter in a different application, all messed up situations in there. Same for unit. If one application is tracking microseconds, the other one milliseconds, you're going to get data that's not really easy to correlate. It has a description, which is human readable, so people can actually understand why you would want that specific metric. And then it has attributes. And these attributes have, again, a type, they have descriptions, examples. And one cool thing is to also have stability and requirement levels to say every application that wants to publish this metric should or must also include the URL scheme or the request method, or add the request method. So this helps us for metrics, it helps us for traces, which have span definitions for attributes that are common across services. It works for logs, which have, or they're called events in this context, like which specific event names should be used for specific things that are happening. And this allows us to build reusable components that are applicable to a broad range of services. But since they are community maintained and broad in scope, this won't have semantic conventions for your application. If you're building a web shop, you won't have a specific semantic convention for every product you have, every offering, shipping methods. Like, that doesn't work. But the cool thing is they're not only like open source and open for contribution, you can just also build your own semantic conventions. Like, it's not that hard. It's just text at the end. If you want to do that, you can. So what could this look like? In this example for this presentation, I'm going to have semantic conventions for a library system, and we have a metric which tracks how many books are indexed by that library system. A shared Google Doc, we just write stuff in there, and it looks pretty similar to what we have in the OpenTelemetry conventions, but this alone isn't really enough. There are some challenges associated with that. Specifically, cross-referencing attributes is pretty hard. We had an attribute for the library location on one metric. If we have that on a separate metric and something changes in that attribute, I now have to go find and replace all the previous instances of that. It's a mess to keep track of. It's also hard to keep the documentation up to date. So if you have this in a Google Doc and your application developers are working in their IDE and add a new metrics, you need some encouragement, or you need to encourage them to actually put that in the conventions as well and maybe have a discussion around it. The discussion aspect also, who owns this? Who has the power to add new metrics? That's oftentimes a difficult conversation to have to find out. And yeah, one more metric won't hurt. I just won't tell anyone about it. And then the enforcement aspect, you can have the best convention written down there, which covers all the use cases. You still need to actually have your teams implement this. You're going to have some way to make sure people use this. And we're finally at the point where the whole title of the talk comes in handy. The last part is OpenTelemetry Weaver. So Weaver is a tool for semantic conventions. It helps us deal with exactly this use case of I want to write my own conventions, or I want to reuse existing conventions and build something with them. At its core, there's the code generation aspect. So you can generate clients, you can generate alerting rules, documentation, everything out of these semantic conventions. But there's even more. Like, you could also have policy validation in there to make sure that the stability levels are followed, to make sure that all your conventions are following a convention. For example, you want to have every metric separated by underscores instead of dots, or some other arbitrary policy. And it also supports live checking. So if you want to make sure that your applications are actually following these conventions, you can send a stream of OTLP data to Weaver, and it will tell you those are conforming to the specs that I have, or there's some violations in here. It is also written in Rust if that's something you care about, but yeah, you probably shouldn't. From an architecture standpoint, Weaver has this weird architecture diagram with a bunch of different responsibilities and repositories and templates and engines and plugins. And to be honest, most of this isn't even implemented yet. It's hard to follow. I've broken it down into a easier to understand diagram. You have YAML files which define your metrics. You put them into Weaver and you get something out of it. Now, what you get out of it is based on the templates you provide. So you could provide templates for Go, and then it will generate Go code out of them. You can provide templates for Python, and it will generate a Python result out of that. So what you can generate is basically up to the templates you provide. And to actually show that this is something that's useful, I've prepared a small demo. I just have to switch this screen sharing target. All right, this is the kind of the state before Weaver. We have an application that is using the Prometheus SDK to define our metrics. And if I go ahead and run this application, wait, I'm in the wrong directory. If I go ahead and run that application, I will see, oh, a location is missing in label map. This is one of the issues I talked about before. If I have just arbitrary string values and I can put everything in there, then I might have actually misspelled location in here, and that's a runtime error, which is bad. So we're going to do a different approach here. So I'm going to remove that. And we're going to take a look at our conventions for this. So we have a metrics file, which tells us there are two metrics that we care about. We have a metric for library books indexed. It is stable, has a description, it is a counter, it doesn't have a unit attached to it, so it's just one book. And then we have attributes, and in here you can already see I'm referencing attributes instead of always putting them in each separate metric. So I'm referencing the library location in here, and I'm also referencing it here. I'm referencing a different attribute over here, so you can mix and match different things in your specification. The other thing you can see in here already is I'm importing stuff. So if I want to not only have my own stuff, but also the upstream OpenTelemetry semantic conventions, I can import that in here as well. And this will be taken into consideration during code generation. The attribute specification isn't much different. You have an attribute group. You specify what the attribute name should be. Is it stable? Some examples for it. Enumerations also have specific members, so you can make sure those are in there. And then I'm going to just run make clients, which will generate my clients. And I've provided templates to generate type-safe clients in my case. So in my Go application, my backend main.go, got rid of the old Prometheus style. And now I have a new type-safe client for my domain-specific metrics. I'm going to increase the font size a bit, so it's a tiny bit too small for my taste. So I have this new package. This is all code generated by Weaver. I can say I want a new metric called, or my new books metrics index metric. I'm going to register that with Prometheus. And now anytime I want to actually set a value to that metric, I need to provide type-safe attributes. So I couldn't just put a string in here. I need to pass specifically a location attribute. So there's no way for me to mess up the label name. I can't mess up the ordering because it requires a specific type of attribute to be passed in here. And this is done at compile time, so I won't have issues during runtime. It all happens during compile time. I'm going to run that again. Application compiles. Everything is good. And then I can check into my monitoring system, and I will see in my metrics browser, I can see the library books indexed metric, and it shows up in here. This on its own isn't that interesting. It's just a counter of 2. So what would this look like if I now want to change that definition? In that case, I'm going to go into my attributes first, add a new attribute for the conference I'm currently speaking at. So this is just a random new string attribute. I'm going to add it to my metric, run the code generation again. All good. If I try to run my application again, it will tell me in a well-formatted error message, you currently only have the location attribute, but you also want the presenting at attribute. So I'm going to take that information, go into my source code. I'm going to add that in here, a presenting at attribute for SREday Paris. Run the application again. Everything compiles again. And then after a few seconds of indexing or scraping, at some point, I get the new attribute library.presenting at. And this is all. I didn't have to, as a developer, I'm only consuming this library. I didn't have to think about what I'm calling this attribute. It's just there for me in a type-safe way. Now, this is all well and good. Like, I have the implementation part of it. I can give this to my application developers and tell them, hey, if you're adding custom metrics, please make sure you have them documented in here and use the type-safe client. But for the query time, this is still hard to parse. I still have to go in and search for my metrics manually, even though I already knew from the schema that all the metrics I care about are in a specific group, and I have the information, which attributes are in there, what else is in there. So what we can do is take the same code generation approach, and since we already had a talk about dashboards as code and observability as code, we can take the schema and generate dashboards out of it. So this is what I did in this example. We have a template for dashboards. And the templates are pretty hard to read. I won't sugarcoat it, but they're using the attributes from the schema definition and building a dashboard as code. So I'll run make dashboards, which will run the schema generation, run the foundation SDK. And now I have a bunch of dashboards. I'm going to then use run make watch to use the Grafana CTL tool. And now I can back into my browser, and I see, since I have the library metrics and I have the HTTP metrics, I can click on either of those, and I have a predefined dashboard which gives me all of my metrics. Since we already know the instrument type, it will run some queries on that, make sure that everything is filterable as well, because the For example, the presenting at attribute that we just defined is mandatory, so it automatically gives me a variable for me to filter on here, and this all updates automatically. I get my different locations. I can filter down by status. So this is really useful if you have a bunch of specifications and want to have an easy to digest dashboard. Of course, this doesn't only work for standard stuff, so I can check out the HTTP dashboard as well. And since I instrumented my applications following the semantic conventions, I will have a panel for the HTTP server request. It's a histogram, so it automatically calculates the different percentiles, and I didn't have to write a single query for this one. So this is the kind of code generation part. So how much time do we have left? Still some time. There's one other thing I'm going to demo, and that is the policy validation aspect. So for this one, let's say we're a developer that has just opened up a new library in the cloud, so it doesn't need a location, but the library is still forcing them to add a location, so they go ahead and say, I don't really care about the location attribute, actually. I'm going to run the make check command, and then Weaver will tell me, let's run this in a different window to make it a bit more visible. In the make check command, and then Weaver will tell me the library books metric cannot be changed because I'm missing a required attribute. So this is pretty useful if you use any of these metrics in alerting rules and you want to prevent someone from breaking the alerting rules because suddenly an attribute is missing and the alerts are no longer firing. So this prevents me, if you run this in CI for your semantic conventions, this prevents me from actually accidentally messing up metrics that someone else might depend upon. Yeah, I don't have a demo for the live checking part, but yeah, it's also a thing. There are some limitations right now. Most of Weaver only works for metrics. There isn't much support for logs and traces. But there is work going on to fix that as well. All right, coming back to the challenges, cross-referencing attributes. We did that. We had one single file for all the attributes and then can choose which one we want for each metric. Keeping documentation up to date is also easier because one of these code generation targets could be a markdown file, which is actually what the OpenTelemetry project is doing for their semantic conventions. They're using Weaver specifications and then generating all the documentation in the website using that approach. Ownership process is also easier to define this way because now all of our conventions live in code and you can use standard tooling like code owner files and pull requests and CI checks to make sure everything goes in there. And ensuring teams adopt a schema, also a bit easier if they have a client that actually helps them, that has IDE support for the metrics, and ideally they just want to use it. If they're not using it and you want to push them in the direction, you can use live checking and maybe alert them and say, hey, you're sending metrics that are not quite following what we want to see. So recap, schemas can help you combat sprawl. If you have 500 different applications sending 500 different names for the same metric, you want to standardize that on one single thing. Weaver can help you build the clients for those teams to make sure that everything is in there. The auto semantic conventions are a great starting point, but technical solutions can't solve social problems on their own. So you will still have to talk to your teams and make sure that you're actually on the same page, you want the same thing. Have recurring meetings to check if you're still kind of recommending metrics that are actually useful from a business perspective. But yeah, so you will still need to talk to people. Sadly, that cannot be optimized. Yeah, that's all I had for now. I think I actually did you all a favor because the food is already here and we were running late before. If there are any questions, I think we have time for a few, but I also completely understand if you just want to grab food and approach me at any time afterwards.